Hey everyone, and welcome back to our electronics tutorial series. My name is Aaron from AX Electronic, and today we are shifting gears and moving on to diodes. So, before we were focusing mainly on op amps, and I remember telling you that op amps are actually a collection of transistors designed to make that high gain differential amplifier. Now, diodes on the other hand are not a collection of other electronics components, they're actually a core electronics component themselves. So they can actually do some pretty cool stuff even though they are super simple. So we're going to start off by just taking a basic look at diodes, then we're going to learn how to simulate them. That way in the future, when we start talking about some cooler diode circuits, you can simulate them yourself. So let's go ahead and get started. So up at the top, a diode is a device that only permits electric current to flow in a single direction. So it'll block it otherwise. Now this right here is the symbol for a diode. Okay, so we have this triangle and a line after it. So it looks, if I were to draw it, I'll draw something like this. Okay, and it is important the direction that it goes. So something like a resistor, it doesn't matter if it's like this or like this. Doesn't matter, okay? But a diode, it definitely does matter the direction because it'll only let current flow in that one direction. So in simpler terms, diodes are like a one-way valve for electricity. So if you remember the water analogy for electricity, a diode is like a check valve. It's only going to let that water flow in one direction, or only going to let that electricity flow in a single direction. If it tries to go the other way, it's going to be blocked. So in this example, this diode would let current flow in this direction. So that's good. If current tried to flow in this way, it wouldn't let that happen. So it would block all of that current that is trying to flow to the left, but would let that current flow to the right. Now, this control isn't free, so diodes do take a little bit of energy to run. So that energy takes the form of a constant voltage drop in the forward direction. So forward direction is the good direction, where it does let current flow. So this is the forward direction, this is the reverse direction. Now, for PN diodes, which is kind of the simplest type of diode, there are different types, but the more general type of diode, the PN diode, has a pretty much constant 0.7 volt voltage drop in the forward direction. Okay, so typical values 0.7 volts for PN diodes. If there is a voltage across it in the other direction, that voltage could be super high. So it could be something like 100 volts, and it's still not going to let current flow. So let's look at a little bit more detail about these diodes. So let's start off with the IV curve for an ideal diode. So I'll make sure that there's a note here. This is an ideal PN diode. Alrighty, so we're going to look at the IV curve. So voltage is on the x-axis, current is on the y-axis. So we know, let me make sure that I define voltage correctly. This is the direction of the voltage. So remember, this would be a 0.7 voltage drop for current to start flowing. So we know that in the negative direction, so in the reverse direction, it is not going to let any current flow, no matter what the voltage is, at least in the ideal case. So that current is going to be 0 for all negative values of voltage. Now, for positive values, we still have that little area, okay, because we do have to have that little bit of energy to make current flow until 0.7 volts. And then in the ideal case, this diode will conduct and form a short circuit. So we're going to say that this current just goes to infinity. Okay, so this is the ideal case. Nothing in this real world is ideal though. So let's take a look at a more realistic curve. So I'll just make a note that this is the realistic case. So diode is still pretty good about blocking in the reverse direction, except this diode is a little bit fragile, okay? So some diodes are more fragile than others, but after a certain point, this diode is going to enter what's called breakdown, okay? So maybe that's not the best look for it. So it's going to enter something called breakdown. So this is breakdown here. And pretty much what that means is that this diode is breaking down and allowing current to flow in the reverse direction, okay? So let me make sure I put V and I here. So in the reverse direction, after enough voltage is applied, it'll start conducting current. And that's usually listed in the data sheet as the maximum reverse voltage. Now in the forward direction, we still have to accomplish that little 0.7 volt drop before we can start letting current flow. And then it's going to look a little bit more, well, it's not going to look more like that. It's going to have what looks kind of like a knee. It's going to look kind of like a bending knee, and then it's going to start increasing exponentially like this. Okay, so this is at about 0.7 volts whenever it starts conducting for a PN diode. And then it's not exactly a short circuit, but it does start conducting current exponentially. So if you increase the voltage, the current is going to increase exponentially. And this can actually be a problem, okay? So that's the next thing we're going to talk about on this slide. So whenever we're actually using a diode, like we said, whenever it turns on, it kind of behaves like a short circuit. It's not exact, but we can approximate it that way. So whenever it turns on, it becomes like a short circuit. And this can be a problem. So short circuits, if there's any voltage across it, is going to cause an infinite amount of current to flow, which is definitely not good. Things can't provide infinite current. So if we're using something like maybe an LED with an Arduino, which is something a lot of people might be familiar with, we'll use something called a current limiting resistor. Okay, now what that resistor does is that it is going to actually limit the current that can flow. Okay, so let's say that we have 5 volts right here. And if we did not have that resistor, if we just had this thing connected to ground, if we look back at our previous slide, this is 0.7 volts. So if this is 5 volts right here, this could be all the way up in the hundreds of amps that it's conducting current. Okay, so that is not good for our Arduino. So what we can do is that we can actually add a resistor here. Okay, so we can add a resistor. Oops. And if this is something like, let's just say 1 kilo ohms, then we know that there is a constant 0.7 volt drop across this diode in the forward direction. So this would be 4.3 volts here. And the current through this resistor would be 4.3 volts divided by 1 kilo ohm, which would be really, really small. So it'd be 4.3 milliamps, which is definitely something that we can provide. So usually whenever we're using these diodes, we're going to need some kind of current limiting resistor. Okay, that's going to help keep our electronics safe, make sure that we're not getting too crazy amounts of current whenever we're dealing with these electronics. Now this is a pretty simple introduction, so in the next video we're going to look at how we can simulate these diodes. We'll take a look at this simple circuit, and then we're going to move on to some of the cooler circuits that we can use. So maybe something like a full bridge rectifier, a voltage multiplier, a max-min circuit, things like that. So if you guys have any questions, please feel free to leave them in the comments section below. Otherwise, if you like this content, please give me a thumbs up and subscribe to see more. And other than that, thank you guys for watching, and I'll see you next time.